Okay, I want to move to a second example of using sigma notation where we need a different, we need to apply a bit of logic to the problem. It's not that difficult, the logic to understand, I don't think, but it is quite, what makes it different is a couple of things I suppose. The first thing is our series is not starting at the first term. We're not interested in the sum of the first 20 terms. We're only interested in the sum of the terms between n equals 6 and n equals 20. Okay? Now, I guess there's a couple. The other thing that makes it different from the previous example is that it is what do we conclude from that bit there?
It's going to go down by 2 every time.
Good. It's going to go down by 2 every time. It's a bit like that gradient stuff from linear functions, isn't it? That's telling you, the gradient, that's telling you whether it's rising or falling. In this case, it's falling. Each term is falling by 2 every time. Okay, so that's just a bit of background knowledge. Now, the underlying logic I would apply here is as follows. I would find, I'll take a temporary diversion and find the sum of this series from n equals 1 to n equals 20. Okay? So, not directly answering that. I would find the sum of the series from n equals 1 to n equals 20. Then what I'll do is find the sum of the series from n equals 1 to n equals
5.
Good, 5. Not 6, but 5. And subtract the answer from that, from my answer to the n equals 1 to n equals 20. Okay? That's the underlying logic. So I'm going to write that underlying logic down. Really what we're doing is we're finding this. Okay? Oops, plus or all. And if we work that out, so it's just a sort of double plunger, isn't it, with you subtracting the answer of that one from that one. Okay, if you follow that logic system, you're not going to go too far wrong. Okay, so once again, I'm going to use the easier of the two formulae we have at our disposal for the sum of an arithmetic series. And by that, I mean this formula here. So in this case, I note, as usual, what it is I need to find out. N, A and L. N, the number of terms in the series. A, the first term. L, the last term. What do we have for N?
20.
We do. It's going from 1 to 20. There are no traps there. There's 20 terms in that series. That's good. Okay, the first term, well, I haven't written it down. I haven't written the first few terms down, but I find it by
Putting it into the formula.
Putting n equals 1 into this formula here, into the rule here. So, 1 minus 2 lots of 1 is 2, so it appears to be negative 1. Okay? So, A equals negative 1. These negative signs can be a menace. There's no doubt you'll find out. Okay, now to find the last term, I would simply
Substitute 20 for the last term.
Yep. 20. Yep, and over here we're going to do the same. That's going to be the last term.
It's negative.
I'm using the 5 there. Okay, so what have we got? It's 20. So it's 1 minus 40, isn't it? So it's negative 39. Okay, so L equals negative 39. Okay, so we substitute away, being a little bit respectful of these negative signs. They can cause us some issues. Let's do it over here a bit. So, what have we got? Sum of the first 20 terms is equal to 20 over 2, I like that because that comes to 10, obviously. A is negative 1, and then plus negative 39. Okay, when we substitute, we've got to be very literal in our substitution. That stays there, L gets replaced with negative 39. Okay, one of my little sayings is, when the signs together are different, you subtract. When the signs together are different, you subtract. So by that I mean that's a positive, that's a negative, we subtract. So negative 1, take 39 is obviously negative 40, but when you are subtracting a negative number from another negative number, why don't you just add them and call your answer negative? That's another way. Okay? Okay, so that's negative 40. That comes to 10, obviously. And then we have a rather easy partial solution, or solution to part of our problem, of negative 400. Okay? Now, over here, so that's the sum of the series from the 1st to the 20th term, which of course we did not want to find out, but we need to, so that we can evaluate from the 6th to the 20th term. So here, it's the same old process, okay? We're going to evaluate that and then subtract whatever it comes to from that, okay? I think we're going to have a minus and negative, so we've got to be careful there again. Okay, so, once again, here, I won't write that down again, but I do note that n equals 5, good. There's 5 terms in our series, in other words. A is equal to, it's the same as what it was here, wasn't it, of course? So, negative 1. The last term, of course, will be different. And we substitute 5 into there and realise that L is equal to 1 minus 10 is negative 9. Does that make sense?
Yep.
Good. So we substitute it into our formula. I don't have a real notation for this, but I might put 1 to 5 there, indicating that we are interested in the first 5 terms of the series. Okay. Now that's equal to 5 over 2, bracket A plus L, so it's negative 1 plus negative 9. And here we have 2.5, or 2.5 if you prefer. Signs together are different, so I'm subtracting a negative from a negative, so I'm adding kind of and calling my answer negative. So that's going to come to negative 25. Okay, so the conclusion I might write up here. Therefore, am I going to have enough room? Therefore, I'll just write it like this. I'd probably prefer to do it differently, to have more room. Therefore, the sum of the series between the 6th and 20th terms inclusive equals that minus, it's always minus in this case, minus negative 25. Signs together are the same, so I am going to add. And that's going to come to negative 375. That's our answer there. Therefore, the sum of the 6th to 20th term equals negative 375. Okay.